Welcome to the tutorial. In this video, I'll be teaching you all how to make Geometry Dash in Gdevelop. Now, Geometry Dash at its core is actually not as complicated as it seems. It's a very simple platformer, so let's just get right into it. Now, the first thing we want to do when making Geometry Dash is when we're making the character is not going to be a regular object. He's going to actually be a physics object because he's rotating and forces are being applied to the cube in this case. So we're going to be first adding a new object, and we're going to have a sprite. Now, of course, we're going to need to make a sprite, and I do have a sprite already made for this my test, but we're going to call this player. We always want to name it player. We're going to add an animation, and then we're going to add a sprite. And here I have my cube right here, and all this is a 32 by 32 cube. All you have to do is go to Pisco and just color a 32 by 32 cube. So I'm going to double click into this, and here I have my player. I'm going to go into behaviors because once again, we don't want to add the platform character. We want to go down where it says physics engine, and this makes it into a physics object. Now you'll see all of these settings, and it's not really complicated when you get to know them. Now this type, you have dynamic, static, and kinematic. Dynamic physics objects, they are like how an object will work in the real world. In a real world, if I push an object, it'll move. If I drop an object, gravity will be applied to it. Things like that. Then you have static objects. Static objects can't move ever, even if you try to apply a force to it. So you don't have to worry about static objects too much. And then kinematic objects, they're like static objects. They don't move unless you apply a force to them. So if you apply a force to them using code, then they'll move. But normally on its own, they won't move. But in our case, we want our object to be a dynamic physics object. We want it to be able to sleep, so that's just better for performance. And you'll see we have settings down here. Now the density, that basically kind of controls almost the heaviness of it, and how it's able not to be able to be pushed over so easily. We want to keep this the same. Gravity scale, I'm going to set this be equal to 2 since we want it to fall a little bit faster. Friction, we don't want to have any friction with the player in our case. We don't want any friction at all. Well, actually, no, we can keep it like this because we're sliding, so we want a little bit of friction. The restitution is like bounciness. So whenever you look at restitution, think of it the same as bounciness. So I'm going to keep this as 0. And linear damping and angular damping. Now, this linear damping means the resistance the object shows towards movement. So if I try to move it linearly, it will show resistance if I have this as a high value. But we don't want it to show any resistance in terms of movement. So we're going to set the linear damping and angular damping to 0 since we want our object to move smoothly. And that's it for the player object right now. And if I drag it onto the scene and I click preview, let's wait for it to load a little bit. You'll see that the player just immediately falls, and that's fine where it is right now. Now, of course, we need ground for the player, so I'm going to add a new object. I'm going to add a sprite, and we're going to call this ground. We're going to add an animation. Once again, I already have these pre-made. You can just create a 32 by 32 cube in Pisco. And we also want this to be a physics object because we can't set it to a platform object because physics objects only naturally interact with other physics objects. So if I were to set this as a regular object, it would just go through it. So I'm going to also set this as a physics object. In our case, we want the ground to never move. So we're going to set it as static. Once again, we're going to keep the shape the same, everything else. The density can stay the same. The gravity doesn't matter because it's not moving. The restitution, we also want this to have no bounciness because if we want our player to never bounce, not only does the player have to have 0 restitution, but what it's interacting with also needs to have 0 restitution. So we're going to keep this the same. As well as the ground, we don't want the ground to have any friction either in our case. The ground and the linear angular damping doesn't matter. I'm actually going to go back to my player. Since the ground is the one having friction, we don't want both the player and the ground to have friction. So I'm going to set the player to have 0 friction. I'm going to drag this ground onto the scene. And I'm going to stretch it out. And now if I preview the scene, the player should drop on the ground with no problem. And that's good right there. And I'm going to go back to the player. Go double click into the player, go to behaviors. Don't check off fixed rotation because we want our player to be able to rotate. So don't check that off. Now I'm going to apply. Now we need to do the regular GD movement. Now the way that movement works in Geometry Dash is not like a regular runner. Normally in runners, the only thing that's moving is the background and the objects, but the player is actually not moving himself. But in Geometry Dash, the player actually is moving, so it's not an illusion. The player is really moving forward and backwards. So how are we going to get this movement done? Now the movement very easy in Geometry Dash, so we want to always be moving forward. So I'm going to have no condition because that signifies always. And then I'm going to add an action, go into player, and I'm going to go into linear velocity. And basically this is how you move a physics object. We could use moving on the x-axis, but it's not as good, it's not as flexible because it's just like a set movement. So I'm going to have linear velocity x, and I want to set it equal to 350, and it's never going to go past that value. So I'm going to click OK, and now if I hit preview, you'll see that my object is always moving forward at a set pace. And another thing you'll see is we can't see our player when it goes off screen. So let's quickly program a camera. The way that Geometry Dash's camera works is not a complicated camera. It is a little bit more advanced than the way that I'm about to do it, but it's not really much different. It's a very basic camera. So once again, I'm going to have the always. We can put it in this same condition because we want this to always apply. I'm going to add an action. I'm going to go into other actions and scroll down until I find layers and cameras. And then put center camera on an object. The object that we want to center on is player. And yes, anticipate the movement because that makes sure that it doesn't get like caught off guard. It's making sure that, yes, it's basically planning on it moving so it won't get left behind. Everything else can stay the same. We don't need any to change anything here. If I click preview, you'll see that now I can follow the player. So that's good. So now that we have the basic player movement, now we have to get into the character being able to jump. So we're going to need a set of variable for this. So I'm going to double click into our player and go into the variables tab and now go to add variable. Now the variable that I'm going to have is can jump. The reason why we're going to do this is because we don't want our player to be able to jump in the air. We need to have a variable that checks whether or not the player is in the air. So we're going to call this can jump, and this is going to be set to a Boolean because it only has two possible values, true or false. So it's going to by default be set to false. So now let's go into our code, go back to our events, and I'm going to add a new event. And now this code right here is going to be the one that's handling whether or not the player can jump, setting can jump equal to true or can jump equal to false. So I'm going to put, for basically right now, I'm going to add a condition and put player, and then I'm going to go into collision. Now, something you need to know, we want to put this collision, this one with the blue thing, kind of the blue thing on the left of the text. Don't use this collision. Don't type it up and use this collision. That does not apply for physics objects. So go ahead and use the collision with the blue thing to the left of it. So collision, I'm going to go down to collision, and we want to check if the player is in collision with ground. If player is in collision with ground, then we want to set the variable can jump equal to true. So I'm going to go into our action player, and then I'm going to type in variable and change the Boolean variable can jump equal to true. So now we know that the player should be able to jump. I'm going to press Shift A and create a new event below. Now we need another code to test whether or not we should not be able to jump. So I'm actually going to copy and paste this because it's very similar code. I'm going to double click into the condition and click invert condition. So now what the code is saying, if the player is not colliding with ground, then we want to set can jump. Instead of can jump equal to true, now we want to set it back equal to false. Of course, this code doesn't do anything yet because we haven't actually programmed the jumping code itself. So let's go program that right now. Now, let's get into this jumping code. Now, the button that we're going to use to jump is space. In Geometry Dash, you can actually use space. You can click. You can use the up arrow key. But for simplicity's sake, we're only going to use space. But it's very easy to add other controls. I'm going to go into add action, other condition, keyboard, and then key pressed. And I'm going to put in space. And all you have to do, you could really put an or condition under this and put or if space key is pressed or if click is pressed, something like that. But if space key is pressed, and we don't want it to be trigger once because you can hold the space button down in Geometry Dash and keep jumping. If space key is pressed, now we want to add a force to the player. So I'm going to add an action, and I'm going to go into player. And not only do we want to add a force, we want to add an impulse. And what an impulse is, it's like a quick little push. It's like a quick little bump. It's like being like hitting a speed bump or something on the road. Like it's just a quick little bump up. It goes on, and then the force stops. Now, when it comes to this impulse, we want to apply an impulse towards a certain angle. Now, since we want to go up, the impulse that we want to go towards is negative 90 degrees. That would be making us go upwards. And you'll see the length, and you'll see all these symbols right here. And it's also the length of it and the force is dependent on the mass of the object. And the mass of the object, of course, mass is controlled by density and volume. I'm literally forgetting the exact formula right now. But let's set our custom size. Let's set the object size to 48 by 48. Because the value that I'm about to use here is going to fit this object size. So let's set it as 48 by 48. And then let's set the length of it to 0.85. Now this may seem really small, but in terms of it's applying a certain amount of force per second. So we don't want it to be really, really, really high, or we're going to be going extremely far, extremely fast. And of course the application point, I'm going to put player dot point x. This is where we want where the force is coming from. This is exactly where the force is coming from. Point x, and I'm going to type in center. Now you may be wondering, where did this even come from, this point? Every object in Gdevelop has a point called center by default. And that, of course, is at the center of the object. So I'm going to copy and paste this out of the x position where we want to originate. And for the second one, I want player.point y. That's the center of the y position of the player. So we want to come from the center of y and the center of x. So that's where that first force is coming from. So basically a space key is pressed, and of course we want to put an and condition for this condition, and if the variable can jump is equal to true, because we don't want to be able to jump in the air. So I'm going to click into player, go into variables, and go into Boolean variables, can jump. If it's equal to true, then this can happen. So if I jump now, you see that I just jumped. I'm going to make the floor much longer so we don't just fall off immediately, so you can kind of see what's going on. So I'm going to stretch this out by a bunch so we can have a lot more space. Now I'm going to preview this once again. And if I press space, I can jump. And I can hold it and keep jumping, because that's exactly how it is in Geometry Dash. Now you may be wondering, how are we going to program the player to actually rotate? Because if you know in Geometry Dash, I've seen this in a few other tutorials, that they don't show you how to actually rotate the player when he jumps. And that's one of the main things that makes Geometry Dash look great. When the player jumps, they actually rotate. And they smoothly land on their side every single time. So we're going to learn how to program that, because that's a major part of making your Geometry Dash actually look good. So I'm going to go back into the events. And now we want to program, of course, the rotation. So when we jump, now we want to add a rotative force. So I'm going to click into add action and go into the player. Now if I scroll down, you're going to not really see anything that's related to rotate. But actually, when it comes to physics objects, a torque is a rotational force. You'll see it right here, torque. And we want to add a torque. I already have these values set up. You're free to do whatever testing you want, but I have a value set as 0.63. And we're adding a rotative force. And this is positive, so it's going to be rotating it right. So I'm going to click OK and preview this now. Now I'm going to press space, and you'll see that I just jumped and it rotated. Now you may think we've already did the solution. We already have a solution to the rotative problem, but we actually are not even close yet. If I hold space, you'll see that everything seems fine, but I'm going to spawn in some more ground objects so I can show you that everything is nothing close to fine when it comes to these objects and when it comes to jumping. Because there's certain limits that we have to know about when it comes to Geometry Dash. Okay, so if I jump, you'll see that I just jumped off the edge of it, and now I'm jumping, I'm doing all this crazy spinning, and that's not how Geometry Dash is at all. So now we have to start setting limits and rules to when the player can jump, even more rules to when the player can jump, and more rules to the player's rotation. So let's get into that now. I'm going to go back into the events, and let's start setting some more rules. First of all, we only want the player to be able to jump if is within certain angles. Now, what do I mean by this? If I look at this cube in Geometry Dash, the player, if I rotate, let's rotate it. The player can only jump if its angle is at 0, if its angle is at this is about 90. Then you have this is 180. This is 90, 180. Then you have 270, and then you have back to 0, or some people say 360, but basically back to 0. So basically we're only supposed to be able to jump if the player is within those certain angles. So this is pretty easy to set. Now we want to add, under where the condition says can jump, setting it to true, we want to add a condition. We go other conditions and put and, because now we want to add more things. I'm going to add a sub condition, player, angle. Now if the player's angle. Now I could use the default player angle right here, and this would still work. But for the sake of what we're going to do a little bit later, I'm going to actually have a variable that is set to this that we're going to use. So I'm going to actually go back into our untitled scene, double click into the player, go into variables, and add a new variable. This variable is going to be called, what's it going to be called? I just forget the name. This variable is going to be called, let's see what the variable name is going to be. Angle, of course. I just forgot. My brain went completely blank on that one. It's going to be called angle. And angle by default is going to be set to a number, of course. And now we're going back into our always condition. And the way that we set a variable equal to a value, we go to this condition that's blank, which means always, add an action. And now we're going to go into other actions, variables. Well, not other actions. We want to go to the object of player, go into the number variable, and set angle. Now we want to set it equal to something. Now we want to set equal to the player's angle all the time. So I'm going to put player dot angle, or not that. Make sure you don't put that, because that refers to the object variable. It's going to be set to player dot angle with a capital A, because that could refer to the player's actual angle and not the variable. So here it is. This is what you want to put. And now our angle variable will always be set equal to that. So now we can go back into this condition, and we want to set the angle in degrees of the player. We want to put if, I'm going to go into our player, our variable, go into our number variable, and if the variable angle is equal to, first of all, 0. That's the original value. If it's equal to 0, I'm going to copy and paste this, and then set, or basically, I didn't mean to put, we have to put or as well because it's equal to any of them. So I'm going to add another condition, add a condition, other conditions, events and control flow, and put or. So now I'm going to put it under here and drag these under the or sub condition. So basically what we're saying, if the player is in collision with ground, and if one of these angles, if the player is in one of these angles. So I'm going to put 90 for the next one. I'm going to paste this again. We're going to put 180, and lastly we're going to put 270 right here. And we don't have to worry about 360 because when it goes to 360, it's basically the exactly same as 0 anyway. So it doesn't even matter. So now the player will only be able to jump if it's within those angles. We don't have to test this right now. And we also want to put for the player can jump being equal to false. I'm going to add a new condition here. I'm going to copy, paste it, and delete the condition that I just made. Now, for the player being equal to false, for the angle being equal to false, I'm going to add a condition. I'm going to put right here, copy and paste this condition right here. If the player's angle is not, and we're going to invert this condition. Actually, we're going to put the sign not equal to. If it's not equal to 0, and we don't want to use or, so I'm going to go into and. I'm going to copy this, paste it in here. And the angle of player is not equal to 90. And you see what we're doing here. We're doing the exact same thing. And if it's not equal to 180. And if it's not equal to 270. If it's not equal to any of those, well, if it's not equal to any of those, can jump equals false. So now, unless our player's angles are either 0, 90, 180, or 270, we can't jump. So that's good. We have those down packed right there. So I'm going to move on to more of our code because we have to set some limits. Now, something behind the scenes that you can't even see right now is that right now our player, the angle of the player is going much over the 360 range. Normally you would think that an object can only rotate from 0 degrees to 360, which is how it normally is. But in Gdevelop, the angle, if you keep adding an angle, it will go over 360 into a higher values. And you see how that's a problem, because that means there's an infinite amount of possible values that will literally be exactly the same as the main 4, 0, 90, 180, and 270. So there's no way we can account for an infinite amount of values. So how do we fix that? The way that we fix that is I'm going to actually add a new event, and I'm going to put add a condition here, player. I'm going to go into player if it's angle, and don't go into the object variable angle. We're actually getting the player direct angle, because this is the real value. So if this angle is greater than or equal to 360, if it's greater than or equal to 360, we want to set it back to 0. I'm going to put trigger once, because we don't want it to keep happening once it does happen once. So I'm going to put trigger once. So basically, if the angle of player is greater than or equal to 360, we want to set it back equal to 0. So I'm going to click into player, and I'm going to go into change the angle of player, and set the angle of player equal to 0. And we don't have to do anything with the object variable angle, because remember, the object variable angle is always equal to the actual angle of the player. So we don't have to change anything there. So now it will actually reset like a regular real world object. So now that we have that, now we have to get into the last thing, which is the snapping. Well, not the last thing, because we haven't made the object killers yet. But we have to snap it. We have to snap the player. Now, if I try to jump, you see that I can't even jump right now. And that's why you have to test your code. You have to make sure that you can jump. And the reason why this is not working, because we weren't using rounded values. You can't see it because I'm not in debug. I really wish I could show you in debug, but it would take a little bit too much time. But actually, if I preview right now, our player can't jump because our angle is set to 0.111 something something. Basically, it's not exactly 0. It's close to 0, but not exactly 0. So that's what we wanted to be the rounded value. So the way that we round it up is we go into our angle. I'm going to put into this condition right here so it always happens. And we're going to set this angle right here. We double click into this. And instead of setting it directly to player.angle, we want to set it to the rounded value of player.angle. And the way that we do this in Gdevelop, we put round first, then we put parentheses, and then we put player.angle, because this is the value that we actually want to round. We put round and player.angle. So now if I preview, I can jump again. I can once again jump. And you'll see that we're running into a few problems. And one of the problems is we're jumping much lower. Much lower. And that's more than likely because we changed the size of our object. And now we're just jumping like much lower. And if I look at the players, 48 by 48. So there's not too much going wrong with that. But it's just, we got to change a few things right here. So I'm going to set this to like 1.3. Maybe a little bit too high. But let's just see how this goes. Okay, that's much better. Still not 100% better, but that's much better. But we're going to apply those changes probably a little bit later, because we can't perfect everything right now. Okay, so everything seems to be fine. We can't jump when we're in between those angles. But now we want to snap, because if you see if I'm jumping now, it's not really snapping the way that we want it to snap. It's not really snapping. So how do we give it that snappy feeling? How it's supposed to be? It's not supposed to delay like that. Now, the first thing we want to do to give that snapping feeling, we're going to have to set some variables. I'm going to explain what I'm doing as I set these things up, because it takes a lot of trial and error. Well, not trial and error, but it takes a lot of explanation for this. But I'm going to make the variables first and explain the things as I get into the code. So I'm going to double click into player, go into variables, and we're going to add 4 variables actually. And these are all going to be called snap. Well, not all of them can be named the same thing. One of them is going to be called snap1, snap2. You can already see the pattern. Snap2. We're going to call this one snap3. And we're going to call the last one, of course, snap4. And then we need one more variable, and this is going to be called nearest angle. This is going to be called nearest angle. And nearest angle is going to be used for calculating the angle out of those 4 angles, because we have the 4 main angles, 0, 90, 180, and 270. Nearest angle is going to be responsible for checking the closest one of those 4 values in which the player is closest to. And of course, these are all going to be number variables, all of them. And we're going to put all of these as numbers. So here we have it, snap 1, snap 2, snap 3, and snap 4, and nearest angle. So now we're going to finally get into programming that angle snapping. Now, I'm going to add a new event. I'm going to just add 2 because we're going to need that soon. So I'm going to add a condition. Well, this is going to be a blank condition. We want to set snap 1. Snap 1. The way we're going to do this is all those snaps that we have, one of them will be doing a calculation of the player's distance from 0. Another one will do it from 90. Another one will do it from 180. And another one will calculate the distance from 270. And basically, whichever one of those values is the lowest, that shows us which angle and which the player is closest to out of those 4 angles. And if it's closest to one of those 4 angles, it will snap to that angle once it hits the ground. So that's what we're going to be doing in terms of the snapping. We're going to be snapping it like that. So let's get right into it. Now, let's have a blank condition here, add an action, and we're going to go into variable. I'm going to go into, player, click into variable, object variable, and we have snap 1. Now, snap 1, how do we calculate the distance? Now, I'm going to put this right here, 0 minus player.angle. We're trying to calculate the player's angle distance. And we're going to use the rounded value, of course. So we're going to use the object, the variable. Make sure to don't put a capital A with the angle. So we're going to put player.angle. And you might think this is fine, but we also want to be the absolute value, which means this value cannot be negative. Because remember, distance can never be negative. So whenever you're trying to do calculations with distance, put the absolute value. Because negative distance doesn't exist, or else time travel would be a thing. So here we have it, we have abs and then parentheses 0 minus player.angle. And we're going to copy and paste this, and I'm going to use this for all of the other 4. And here we have it. I'm going to change this. Make sure you get these all changed. It's very easy to forget. Change this to snap 2. Change this to snap 3. And change the last one to snap 4. And maybe so I can win into it. Make it into snap 4. And instead of putting 0 minus, for the second one, snap 2, we're going to put 90 minus player.angle. And the third one, we're going to put 180. And of course, the last one, we're going to put 270 minus player.angle. And now that we have all these snap values, they're going to be calculating the distance. Now that we have them calculate the distance, now we want to check which one of them is the lowest value. We're going to check which one of them is the lowest out of the 4. And depending on which one's the lowest, that's what we're going to set nearest angle to be. Now, we'll start with snap 1. So we have this added condition right here. The first thing we want to do is check. I'm going to add a condition. Go into player and go into variable. So we're going to the object variable. The number variable. We want to check if snap 1 is less than player, and we want to access snap 2. Player, so we put player.snap 2. Don't put snap 1, player.snap 2. So we're checking first if snap 1 is less than snap 2. And I'm going to put a condition, and now we want to also put if snap 1 is also less than snap 3. And you can see what we're doing here. We're checking if it's the lowest one. I'm going to paste this one more time. And if snap 1 is also less than snap 4. We're checking if it's less than all of those. If snap 1 is the lowest value of all of them, that means we know that the nearest angle of the player is 0. So I'm going to set go into player, go into variable, change number variable, and then nearest angle is going to be set equal to 0. That's what it's going to be. So here we have it right here. And you can see we're going to do this for all of the other ones as well. So this is going to be a little bit tedious, but it's not going to take too long when we get through it. I'm going to copy and paste this right here. And for this, we're going to put snap 2. If snap 2 is less than, instead of putting if it's less than snap 2, if snap 2 is less than snap 1, if snap 2, Basically, went to the help page of Gdevelop. Whoops. If snap 2 is also less than snap 3, and we also want to check if snap 2, of course, is less than snap 4, then we're going to put the nearest angle. That means it's 90. And you can see what we're doing here. We're going to keep doing this until we have all those 4 angles. Now we want to do snap 3. If snap 3 is less than snap 1, that's fine right here. If snap 3 is also less than snap 2, we don't want to check if it's less than itself. If snap 3 is also less than snap 4, we can keep that same. Then we set the nearest angle is 180. And last but not least, we need to do this one more time for snap 4. I'm going to copy and paste this one more time. Now we want to check if snap 4, if it's less than snap 1, we can keep that same. If snap 4 is also less than snap 2, we can keep that the same. And last but not least, if snap 4 is less than, instead of putting snap 3, or snap 4, we're going to put if it's less than snap 3. Then we set nearest angle is 270. That's all it is. Now that we've did all that stuff that calculates what the nearest angle is, how do we actually program the snap? The way that we program the snap is very, very easy. I'm going to put Shift A and add a new event below. And I'm going to put add a condition. If player is in collision with ground, I'm going to add a condition. Trigger once. We don't want this to keep snapping. Trigger once. And we want to change the angle. Add an action. Go into player. Type in angle. Change the angle of player to be equal to player. And we want to access the variable nearest angle. So I'm going to put player.nearest angle. And now, basically, the moment the player touches the ground, it will immediately change the angle of the player to the nearest angle. So you don't have to wait for it to rotate onto its side. It will just immediately snap there, as it should. So that's what it's supposed to do. And another thing that I didn't show yet is we also want to... Well, let's preview first, because we haven't done any testing in a while. If I jump, you see I jump a little bit high, and it snaps. Now, it's a little bit of a rough snap, because the way that I made the jump, it doesn't actually directly land on its feet, and that's what it's not supposed to do. Let's try 2.2 as the length of the jump. 2.2 is pretty good, but not 100% there yet. Let's try 2.3. And you'll see that will snap better. And like I said, once again, this is not a very good jump, I'd say, for this code. In this sake, there's not a very good jump. But you can make sure you tweak around with the gravity scale, and also make sure to tweak just tweak around with everything to make sure that everything is going fine. So now that you see we can jump, you'll see that there's a few problems already. You'll see that sometimes it will jump backwards. And the reason why that is having all these problems is because the order of our code, mainly. The order of code is very important when it comes to programming. We can't just put anything in any order. So let's change. Okay, so I found the bug here. And the bug is I literally have to change the code. This jumping code has to be in between this player colliding with grounded being set to false, and this can jump also being set to false. Like, the order is very important, because you see that we have the logic right, but the order of the code wasn't right. So whenever you have your logic right, but the things are not working correctly, you have to change the order of code sometimes. So if I do everything now, everything is completely fine. I changed it back to my original value of 0.85, and you'll see that I'm jumping smoothly. This is how Geometry Dash is supposed to be. And lastly, we have no enemies, or of course no spikes or things to kill us in Geometry Dash right now. So we're going to add those right now. Now, of course, one thing we're going to add before that is limiting the player's rotational force. Because I haven't shown you yet, but if I fall off, let's just fall off. Let's go shrink this edge. Zoom out and shrink it by a bunch. And I'm going to fall off the edge. And if I jump off, you'll see that I'm rotating. And it's kind of hard to see here. Actually, let's keep it the same. Actually, let's not keep the same. Because the player's rotational force, it should be limited. Now, you can't see in that circumstance, but in reality, it can actually go up to an infinite speed. And of course, in Geometry Dash, our rotational speed is pretty much set. It's not, we can't just go infinite. And the way that we're going to do it is we're going to keep this condition blank. We want this to always happen. I'm going to go into player, and then I'm going to put angular velocity. That controls how fast it rotates, of course. I'm going to clamp it. And what it means to clamp, when you clamp a value, you're limiting it between a minimum and maximum value. Now, the first parameter that we want to put is the player's current angular velocity, because that's what we want to limit. So I'm going to put player.physics, and then I'm going to put physics 2, because that's the thing, right, that we want. And then I'm going to put angular velocity. That's what we're trying to access. Angular velocity. And now that's the first parameter, because that's the value. We're going to put a comma. The minimum value is 0. And the maximum that we're going to have is 150. So that's how we clamp and limit. And I'm not going to test that. Now, the last thing we need to do is set things that kill the player, which are not hard at all. So, of course, we're going to need some killer objects. And the two things that kill players mainly, there's a bunch of objects that can kill the player in Geometry Dash. But in normal Geometry Dash, you have spikes, and then you have blocks can kill the player. Just by touching the side of a block, you die in Geometry Dash. So how are we going to do that? Now, first we're going to start off with the spike. And I'm going to add a new object. Make a sprite. And I'm going to call it spike. And I have a pre-made sprite for this. All you have to do is go into Pisco, make 2 lines that go up to the top. Make sure it's still 32 by 32. But here's a spike object. And I'm going to hit apply. Now if I drag this onto the scene, I'm going to set the spike at the same size as the player, which is 48 by 48. Here it is. And it's set the same size. And here, when we touch this spike, we want the player to die. Simple as that. And I'm going to double click into the spike and edit its collision mask. You see, this is a problem. This is a square hitbox on a triangular spike. So I'm going to use a custom collision mask. I'm going to drag these vertexes to make the spike hitbox much more accurate. Nothing has to be perfect right now. We're just going to just make it much more accurate than it used to be. I'm going to hit apply, and now everything should be fine. Now the spike is very simple than just dying from a block. So I'm going to add a new event. Well, not add a new event. I'm going to put right here, add condition. If player is in collision. Now we're not using a physics object collision because remember the spike is not a physics object. So now we want to put regular collision because the two objects that are interacting are not both physics objects. So if player is in collision with spike, that's the condition. What we want to do is delete the player. We're going to delete the player. That signifies his death. So I'm going to hit preview. And if I touch the spike, I die. Now when it comes to the block, it is it's not much more complicated, but it's a slightly more complicated. So when it comes to the block, we want the side of the block to kill us, but we also still want to be able to jump on top of it. So you see this is a little bit different. Now for the block, we're going to still be using the ground, but you could make it a separate object if you want. But set the size as the same as the player for this case. Every case is a little bit different. But let's make a new object I'm going to call it kill side. Basically, only the size of the object will kill us. Add an animation and add the sprite. Of course, this could be any sprite you want. It doesn't matter what it is. I just have a placeholder already set in. Gonna hit apply. Now, basically, what we're gonna be trying to get happen, we're gonna be trying for this to happen. What's going to be happening is basically we're gonna stretch it out like this. Of course, this will be invisible. This red object will be invisible. Basically, gonna be like this. The hitbox will be something like this. Basically, you still die from touching the bottom or side of a block. But you see, you still have a little bit of leeway up here for your block. You still have a little bit of leeway up here for your block. So let's get into that right here. Now, of course, we're going to go back into the code. I'm going to add a new event. We also want to set it so if the player is in collision with kill side. If the player is in collision with kill side, we want to also delete the player. So I'm going to copy this and paste it. And this will also delete the player. Now, in terms of making this flexible, because we don't want to have to individually set up these objects on each block that we put. That would take forever. We would never be able to make any actual good levels. So, the way that we do this is for each of the objects, we want to create this object on the ground. So, how are we going to do this? I'm going to go back into our code, click into this condition, and just click on it. Don't actually click into the condition. Go to the top right where it says plus. Now these are special conditions. And the one that we're going to use is for each object. Now for each object, this will be repeated. So basically for each and every one of our ground objects, this code will automatically run for them. So for the object we want to repeat for is ground. And we only want this to happen once. Basically we're going to be creating an object. We're going to be creating a kill side object on each block. So we only want this to happen once. So I'm going to go into add condition, go into other conditions, and put trigger once while true. And now we have that right here, trigger once while true. And I'm going to add condition. And the object that we want to create is kill side. So I'm going to go into create object. And I'm going to put the X position. Now I have this set up. But what I'm going to do is ground.x. We want it to spawn at ground.x first of all. And I'm going to put -2. Now these are set values. If you're going to make your own geometry dash, you're going to have different size blocks. You want to create this position based on the size of the block, of course. So you will have to change this if you set a different block. Now that's the X position. And the Y position we're going to put is ground.y. Put parentheses. And then I'm going to put +3. And of course we want to spawn it on base layer, that's fine. And lastly, let's go back into create object. Lastly, we want to make it so the size of kill side will automatically be a specific size. Because as you can see right here, this size right here is about what we want, but not exactly. I'm going to add a new event. Do not put it under repeat for each instance of ground. Don't do that. I'm going to put no condition here because we want this to always happen. I'm going to put change the size of kill side. Change the size. I'm going to click into size. And the width is going to be 53. Once again, these are preset values. Change these according to your block size. If you want to say something different. 53 by 50. This is the size that I'll always be at. Now I'm going to spawn a few blocks and show you how this is flexible. I'm going to put a block right here. I'm going to duplicate it by right clicking, or you could use Control D. I'm going to duplicate this. And I'm going to duplicate this again. And you'll see that if I touch the side of this, I die automatically. And that's one thing. But you also see if I jump on top of it, I can successfully jump on top of these without dying. And also, I haven't shown you this, but if I jump on the bottom of it, because this is also true to GD, I also die if I jump on the bottom of it. So this is how geometry dash actually works. So that's it for all of the code right there. One more thing, you want to hide these kill sides. Of course, you don't want the player to be able to see that. So in order to do this, just put under this condition always, go into kill side, and all you have to do is hide. Just click hide. And now the object will always be hidden. So if I click into it, these just look like regular blocks now. You can't even tell that they have something on the side. So this is how you make geometry dash in Gdevelop. This will be the end of the tutorial. I hope you all enjoyed the tutorial. If you want a part 2 of this geometry dash tutorial, make sure to like, comment, subscribe, and make sure you comment that if you want a part 2. Also, I've heard a few people, if you want a 3D geometry dash, make sure to also comment that in the description, well, in the comment section as well. I want to thank all of you for watching. I want to put my member, my name at the end of it as well. I want to shout out to all of my members. But I want to thank you all for watching once again. If you want more tutorials, make sure to hit that like button, subscribe to the channel, and hit the notification bell so you never miss on any new Gdevelop tutorials. I want to thank you all for watching for the last time, and I'd like to leave this video. This is the end. See ya.